So I just started working on this particular problem, which the problem statement is quite clear. We are given a nums array. We need to sort the array in ascending order. But the core idea is to write an optimal solution. It's not about just writing a sorting function, but it should be optimal as well. So clearly there are limited options that we have. The core two options that we have are how do I use this? Open. I've never really used this, so yeah. So the two options are merge sort and the other one is quick sort. And from what I know, merge sort is likely n log n, and the other one is n log n, but in the worst case it can go to n square, right? So these are the two options we have, and here I have tried to do this using a merge sort, and so I'll be explaining the core idea of merge sort in as simple as I can. So I have not really understood it as well. Most of the solution is copied, as you might expect from me, but I am yet to deeply understand this idea. But I think I've gotten a pretty clear idea for now. So let me try to explain this. Do I need to remove this? Yeah. So merge sort is pretty simple. So let's say, do I really need this? I think I will use something else. Or raw, solid raw. Yeah, better. So let's say we have got an array 5, 3, 1, 2. Okay. So merge sort is simple. We first split the given array recursively. So it will be split into two parts. Let's say this and this, and further it will be split into two parts. There are two elements, so it will be 5 and 3, and this will be split into 1 and 2. Cool. I think pretty cool. So the first part has been done. The next part is we have to merge this. So this was the divide part. So it is fairly simple for now. And the other part is simply merging them recursively. So these will merge into a subarray 3, 5. These two will form 1, 2. Further, we will need to merge these into a new array that has to be returned further. So this is the core idea of merge sort. So now let me try to explain the solution that I copied, just to be clear. So there are two functions. For the sort array, there are two functions. It can be done in one, but in order to simplify the core idea and to keep the solution pretty modular, we are using two functions. And as far as I've seen, most of the solutions that use merge sort usually have two different functions. So that is pretty common design pattern that I have come across. So the first function is merge sort, and we are having an array, the left pointer and right pointer. So why do we have the left and right? So that's a pretty good question. It is because merge sort has to be recursively applied. The left and right pointer essentially provide us a means to check for the base case. So if the left and right pointer are equal, that means we are having a single element. So if that's true, we return the array. That's the base case. Of course, every recursive function has a base case, so this is the base case. So if that's not true, we will calculate the middle index, and we will apply merge sort again on that. And so this first function calls merge sort in this part and this part, and finally we call merge. So why have we called this here? So that's a pretty good question, and I myself am not really sure why we are calling this. So okay, so this is returning the array, right? This will return the array. This will merge. This will merge. So everything is being done on this arr. So this is likely a copy that is being passed. I will need to check for that. What really undergoes in Python? Are arrays passed by value in Python? I think I'm reading the question. Not passed by value, where a complete copy of the data is made and sent to the function instead for you is passed by object reference. Okay, so the original list is modified. That is the claim that is being made. Okay. I think that's pretty cool. So we are not using the copy. Okay. So the array is not really being modified. So the left and the middle pointer. So this merge sort, calling this will eventually do what? That's a good question actually. I'm not sure what is happening here. Merge sort being called on air. Let us try to understand the remaining part for now. I think if I keep pondering on this part, I'll be stuck for quite some time. So let us skip this for now and try to understand the parts that I have gotten a pretty good understanding. So we are calling this on the left part and the right part. So simply this is the indexing, material plus 1 to right. So two sections have been created. So if I have to just illustrate the idea, so let's say this is an array 5172. So let's say this is the middle point. So I get to this part and further to this part. These two are further splitted in the similar fashion. Split in the similar fashion. Split is not a word, right? So yeah. So this is being done here. Finally, we merge them using this model. So likely what is happening here is when we call this, what really happens? Okay. I think I get it. So this is the thing about recursive functions, right? You get confused if you don't see the entire picture. So merge sort is being called here. So the recursive call that will be made in the end will eventually modify the array, right? So the array will be modified and the section will be, sorted, right? So this will be happening in a recursive fashion. So for example, the last recursive call will be made on a single element and of course it will be sorted by default. Further, that recursive call will help resolve another recursive call that might be having two elements, and that will lead to a merger that will use this function to provide a sorted array to the other recursive calls if it is not the last call in the stack or whatever. I think that's pretty clear. I think I was to some extent able to understand this, but really there are a lot of gaps in my understanding. So we will surely revisit this. But now let's come back to the merge part. So the arguments are nums, left, medium, the mid and right. So this can actually be derived, right? The mid pointer can clearly be derived using the left and right pointers, not pointers, like indices. So the left, we are creating a left subarray that essentially uh, uh, is the left section of the array that we are trying to actually merge. So usually we will have two parts, and we will be using those two subarrays, and we will try to merge them and create one. Not trying, we intend to do that. I'm really lacking words here. So another subarray will be the right. We are just naming them as we might like. We can even name them L1, L2, whatever we like. So now we are having three, iterators that we'll be using to actually merge them. So the I is the uh, pointer that we will use to simply iterate through the nums array. Essentially, we want to modify the entire nums array and provide with the with the sorted one, right? We are actually doing this in place, if you get the idea. So j and k are being used to iterate through the left and right subarrays that we have just initialized here. M plus 1 is not inclusive, just note I wrote for myself. So j and k are simply being used for iterating through left and right subarray, as the name suggests. So we are creating a while loop here, and there are multiple ways to write this, but this is the one that is likely the simplest. While j is less than left and k is less than right. So ideally this condition gives us a means to merge. Actually, this is the core part of the merging. Of course, this does not completely create the nums array that is required to be finally returned, but it to some extent it does the core part. So this condition allows us to create the sorted portion successively, or cumulatively. So the condition that we first check is if left j is less than right k, the kth element. So if this is true, that means the first element of the left subarray, I think our example might be good. So let us assume that left is equals to 5, 3, 1, yeah, and right is equals to, let's say, 17, 3. Okay, this needs to be sorted, right? Because the merge is only applied once that has been done. So change this to 3, 5, 11, and this will be 99, 105, 12. I think that's enough. So in the first iteration, I will be showing the first iteration. What will happen is the first condition will likely be false because we will be starting at the very beginning. So j and k will both be 0, initialized to 0 in the beginning. So first thing we will be checking is the condition will be true, and we will get into the while loop, and the if condition that first will be checked. So left dot j means left 0 is less than right 0. So that is clearly true. So this will happen, and so the nums 0 will be initialized to 3, yeah, and of course now j will be incremented to 1, and this will keep happening. I think one iteration is more than enough. So once this is done, likely not likely, it is very sure that there will be few elements remaining in any one of the two subarrays that we created, left and right. So in order to merge the remaining arrays elements, we will be adding two more while loops. So at first, when I came across this pattern, or this or whatever approach is being used, I was pretty confused, and I was not sure if this is intuitive or is the best way. And likely this is the best way, because we are not really sure which array will have remaining elements, subarray will have the remaining elements. So in order to prevent that, or really not complicate the code, we simply create two while loops, and we simply merge the remaining elements that are pending or are remaining in any one of them, and this will likely create the final solution. And once that has been done, once, actually not once that has been done, but rather we just apply the merge sort, and merge sort uses the merge as one of its internal functions. This can be done inside as well. So merge is actually a helper function in this context, and merge sort itself is a helper function to sort array. Right. So it's more about modularity and a bit of confusion here and there, but I think it's a pretty good design once I get into the regular practice. So yeah, that's it for now, and let's try to just submit this. Of course, I've done this already, and yeah, it did pass. Let's actually check the whatever this is, time complexity. Yeah, time complexity. Let's check this as well. And from what I really understand, the space complexity should be O of 1, because we are not really using any space, right? And O n log n is likely that. So okay, so space complexity is O of n. Are we using any space? Okay, so we are initializing the left and right. So likely that is what is responsible for O of n space complexity. I'll likely verify that, but later.